The device sets up a field, which we call a gate, and as the passengers move through the field, they're wearing a device which is activated by the field and somehow records or sends a message that I've passed through that field at this particular time. That's how the two devices work. Now, we actually examined RFID because we thought that was going to be the best way to do it, and we found there were lots of problems of RFID. The RFID system works by having a set of receiving and transmitting antennae. You need a reader, you need a PC computer attached to the reader, and then you need to have the passengers wearing a tag. And they can wear a tag either around their wrist, around their neck, around their ankles, however, wherever. What happens is that as the passenger passes through the radio frequency gate, it excites the tag. The tag is then excited and it sends a signal to the receiver, and then the receiver logs the fact that that tag has passed through that gate at that point in time. You need a PC attached to the reader, or you can have some devices can load all the information directly on the reader as well. But the one that we looked at had a PC attached to the reader, so it was dumped immediately to the reader. That's the RFID system. Now, in this diagram here, you can see what you have to do to set up the RFID system. We've got antennae, in this case, located here and here. We've got a reader located here. These all have to be powered, so there's cables running all over the place, and then it's got to be hooked up to a computer, and so there's more cabling to the computer. This is a nightmare to set up. It takes a long time to set this up, and the efficiency of how good the pickup is depends on how you orientate these things. And so there's a lot of activity, you need to do a lot of work to set this up. So here's an experiment that we did in one of our corridors at Greenwich. We did a lot of these experiments. These guys are wearing a tag around their wrist, and they're walking through these devices. And we just wanted to see, in a relatively high density crowd, how many tags would be picked up. What we found was, through doing a number of these corridor tests, and the crowd wasn't actually very large, only involved 12 people. Once we got the antennae set up optimally, we were picking up 75% of the people wearing tags. Now, 75%, other people have reported about 50%. We've managed to get 75%, but 75% is rubbish if you're going to use the data for validation of evacuation models. Picking up 75% of your people is not good. We also did a couple of other tests, as you saw there, where we got the passengers, the test subjects, to try and fold their arms to pretend that they were doing things that passengers might do on a ship to cover up the tag. And when that happened, the read rate dropped to 17%. We got very, very low read rates, very, very low success rates. We also did the test on board the ship because we wanted to see, does the metal environment of the ship, does that affect the read rates? And we found that it didn't actually detrimentally affect the read rates. Okay. So these types of RFID systems we use are called passive because the tags are just passive tags, they're not powered. What we found was that the poor read rates were not sufficiently reliable for evacuation analysis. The human body actually interferes with the radio frequency. People are effectively bags of water, and water attenuates the radio frequency signal. And so bodies actually block the signal. Also, the way the tag is orientated has a big effect. If the tag actually comes into contact with the skin, if the actual tag component comes into contact with the skin, it doesn't work. So you have to make sure that the bracelet or the thing around your neck is designed so that it doesn't come into contact with the skin. The antenna setup is time-consuming and complex. It requires a lot of cabling, which is dangerous in terms of trip hazards. It takes a long time to set up. Also, the logistics of transporting all of this equipment. The antennae are huge. Logistics is a nightmare. And you've got the added problem that different countries have different regulations about the transmitting frequencies of these things. So you can't take these devices from the United States and use them in Great Britain, because we have different laws about the radio frequency transmission rates. So there's an issue there if you're going to use these devices cross-border about what device you can use. So we ruled out, and we were quite desperate, we ruled out radio RFID, and we weren't sure what else we were going to use. We came across a company who produced infrared tags, and we had a look at the infrared tags, and they didn't quite work. They weren't quite what we wanted. They didn't actually give us a high read rate. But the company agreed to work with us, and we redesigned the tags, and we redesigned the beacons with the company. And basically, we got the redesigned tags, and we set them up, and we ran a similar set of trials. Now, the difference with these tags is that each of the tags has a memory on board. And as each person wearing a tag passes through the gate, it does a handshake with the gate and it stores in its onboard memory, I passed gate 23 at this particular time. There's a clock and there's a memory chip inside. So the tag records all the gates it's actually seen. The way the tag